Hi everyone and welcome to this episode of Keipert Labs. In today's video we're going to be discussing the parts of a scientific report. So firstly we're going to talk about what is the purpose of a scientific report? Why would we bother writing one? And then we're going to go through in detail each of the parts of the scientific report, from the aim to the hypothesis, the materials and method, the results table and results graph, discussion, conclusion and bibliography sections. So we're going to go through what each one looks like, some of the key, excuse me while I adjust in my chair, key features that each one needs to have, and also with a bit of an example of what it might look like. Okay, so why would we bother writing a scientific report? Well, essentially, you've conducted a scientific experiment. You've designed it, you've planned out this investigation, and so you need to report on your results, what we would call your findings. So you need to sum up what happened and how it went. And it also, the report format and the way that we actually write one, it helps to address or answer lots of different questions about your experiment. You know, like what happened? A kind of simple recount. What did you observe? What did you measure? What sort of things were you looking at, and how did you go about it? What patterns did you notice? What trends? How can we try to explain and conclude about what happened? And then also some kind of more analytical skills about being able to look at your experiment and think about, was there a better way that could have been done? Were there any problems that came up that if you were to do it again, or if someone else were to do it, that they could take note of to help them in planning it out? Okay, so it helps you to demonstrate and to practice each of these skills, and also provide something that another scientist of an equal skill level can read and understand exactly what happened. Okay, so firstly we're going to start with the aim, a clear statement of the experiment's purpose. What are you setting out to achieve? What question or problem are you trying to answer? The aim is in this statement that we mention the variables that we are changing and measuring in our experiment. So if we do this, what happens to this? So an example I've got written in here in bold, to measure the effect of drop height of a tennis ball on its rebound height. So if you're to take a tennis ball and you're going to drop it from certain heights, how does the height that you drop it from affect how far it rebounds? Okay, a really straightforward scientific experiment, but it's got a lot in it that you can analyze and you can dig into. But so you're stating your purpose up front as a statement rather than a question as such. And then we get to a hypothesis. So to take this aim of the purpose and to actually provide a statement that predicts what you think will happen in this experiment. Now you take yourself out of the equation. We don't use words like I think and so on in a hypothesis, but you are making a prediction that sometimes you're in your hypothesis as you get to higher levels of science that we're trying to give an explanation that's based off previous knowledge, other observations, research we might have done to prepare, and so on. Okay, so here's a statement. If the drop height is increased, then the rebound height will also increase. So it mentions both variables, but it is a statement of a prediction. Okay, so now that prediction might be fairly straightforward or it may not be. The prediction may be right or it may be wrong at the end of the experiment. But the experiment's all designed around testing this statement out. Okay, think about it like what Mythbusters do in making, deciding if they think that the myth is going to be, it's going to be busted, confirmed, or plausible. That from the outset, they make a prediction, they do the testing, and then they conclude at the end based on what they predicted. They look at kind of what they saw to help them to make the decision. So then we get to our materials. So a scientific diagram or perhaps a photo of the equipment and setup that you used in your experiment. Okay, it needs to be neat and labelled. So here we've got from an experiment, not thinking about bouncing balls for a moment, but we're thinking about germination of seeds and the effect of a microwave on it. So this student here, this is actual student work, has actually drawn an example of where things were placed on a saw. So they've labelled each of the parts. They've given detail to help another person to be able to set up the experiment in the same way. A photo is really, really useful if you're able to take one, because then it really helps to capture a lot of detail about how the experiment was done. And then we get to our method, which is our procedure or our instructions, like the steps in a recipe. It's a series of numbered steps, each starting with a verb. So thinking about an action, thinking about what each stage is going to involve and the order in which it needs to happen. So it's sequential, we would say. It follows a process or an order. And that method describes two things, how you're doing it and how to do it safely. So you're thinking about safety in your experiment and controlling the variables to make sure it's a fair test. Okay, so it must include enough detail so that another scientist of the same sort of skill level could repeat the experiment. So thinking about our bouncing ball experiment, you can see a numbered list of some steps here. Each one starts with a verb: place, hold, release, and then repeat. It specifies what needs to happen, the order it needs to happen, and enough detail to tell a person how to do it properly. Okay, this is like what a good recipe should be about. If you're trying to cook a new dish, you want the instructions to be detailed enough to give you the best chance of making it properly, rather than leaving too much to the imagination to get it right. Okay, so it needs to be detailed. Think through, thinking it through from the perspective of a novice or someone who hasn't done it before. Think about what they need to know. Okay, so then we get to the stage of collecting our results into a table. So firstly, the purpose of the table is to display the data you collect in your experiment. It needs to, and it's a particular structure that helps us to do that effectively. We are arranging data in columns that each has an appropriate heading with units if relevant. So whatever was used to measure that particular variable. We have columns for 3 trials and an average as well. That's really important so that we can recognize that our data is not a fluke, that we can identify patterns that are consistent. Okay, so here for our bouncing ball experiment, we've got the drop height, a column for that, and then we've got columns for rebound height, which is our measured variable. So trial 1, 2, 3, and then a space to calculate an average value based off adding those 3 things together and dividing by 3. And then we set a new drop height, and then we can repeat. A new drop height and repeat. Okay, and it puts all that data together really neatly. Now, just a little pro tip for you, because we include units in our headings in brackets, that you don't write units in the boxes in the table. So you wouldn't write meters up here and then write M for meters in every other box. That's the point of putting this up the top there, that you can just put numbers in the table and we know that it means we're using everything's in meters. And it's also appropriate to be using a title. I wasn't able to fit it here for you to see, but so that the table stands alone, that you can understand what it means. But a table can't show our data all the patterns that we need, that we often need to use a graph. So we can visually display any trends or patterns in our data. It makes it really clear to see. A well-constructed graph, can stand pretty much on its own without the rest of the report. Okay, we choose an appropriate graph type, whether we're looking at column or a line graph, depending on whether we're doing, whether we're doing measurements or things that are word categories or things that are number measurements. And we've also make sure that we're only using our average values. Okay, we're not doing it for all of our trials. That's the point of calculating the average. And so our graph needs to have a lot of the relevant features. So we need to have a title. We've got to have labels with units on our axes, so our horizontal and our vertical axis. We use appropriate number scales using a consistent spacing so that we can represent our data accurately. It's important that you get the details right, okay, because a good graph really makes the difference. And then we get towards, kind of the analysis part of our experiment. Once everything's done and we've shown our results, what can we learn from it? So analysing any trends or patterns, things that we can identify, relationships between our variables in the experiment, that as this happened, this happened. Okay, and then also trying to not just say this is what did happen, but why did it happen? Explaining these patterns and trends. Okay, and that might involve doing further research. It might involve prior knowledge or other experiments or conversations or things that help us to find an explanation. But research is the main thing that makes the difference here. Saying, okay, well, this is what I noticed. Why might that be the case? And then trying to find an answer from others who may have looked into this area, especially if your experiment is something that other people have done before. We also want to evaluate our experiment itself. So thinking about, okay, how did it go? Did you have any problems? Were there things that could have been done better or perhaps extended? Was it a fair test? That is, were you only changing one variable at a time? And if not, why not? What could you do differently? Okay, so that actually gives you that reflection on how the experiment went. Okay, that's also useful for planning additional investigations or to show someone else who's reading it that you can kind of think about how you went, not just kind of do it and move on. Okay, It also is the space to address any relevant questions that might be asked. So it might be asked to dig deeper into particular areas, and so this is a section where you do that. Okay, and then we come to a conclusion where you're basically summarizing or summing up your findings. What at the end of the day, what did you notice? Specifically relates or refers back to the aim and the hypothesis. So you're reflecting directly on what was the purpose of the experiment as a whole. Okay, was the hypothesis proven to be right? This is like what Mythbusters would do. They'd come back to what they predicted and say, was the myth busted? Was it confirmed? Was it plausible? How did their data, how did their results lead them to that kind of making those statements? So for our example, as the drop height for a tennis ball was increased, its rebound height also increased. Simple, summing it up, mentions the variables, reflects back on both the aim and the hypothesis, and then in this situation we see the hypothesis was proven correct because this was something that we had predicted. Okay, and so you can reflect that as well. And lastly, we also have a bibliography. So it's important that if we're seeking outside sources of information to help us, that we can list the references of the sources we used. So we're giving credit where credit is due. Okay, so that we're not just saying that everything came totally from the top of our brains, but if we had help from elsewhere, that this was the source. And it also includes an appropriate referencing style that includes detail that allows someone else who's reading it to access the same research if they want to read further. Okay, and so here's an example, thinking back to that seed experiment rather than the handball experiment. So it's a particular reference. It includes a link. It says who published it and when, what it was called, when the person accessed it, in case it's a site that changes regularly, things like Wikipedia. That's really relevant. Okay, and so this helps to make sure that website is given appropriate credit. Okay, so we talked through what was the purpose of a scientific report, and we went through in detail each of the different sections. Okay, and so what do you do, what do you include in order to make sure that report is thoroughly put together? All right, thanks very much for watching. Bye for now.